Okay, this is section 11.4 again. Sometimes you'll see it written down as 3.2. We're going to talk about actual conditional probability in this section. Okay, we've got some objectives here. We're going to determine the conditional probabilities. We're going to distinguish between independent and dependent events. And we're going to use the multiplication rule to find conditional probabilities. Now, we talked about in the last section simple probabilities. Well, conditional probabilities are a little bit different. Conditional means usually there's some kind of condition to it. And what that means is that there's one thing that happens that affects the other, or it may not affect the other. Okay? So, conditional probability is the probability of an event occurring given that another event has already occurred. Okay? So, it's sometimes written as P and then parentheses B and a line A. And what that's read as, it's read as the probability of B given that A has already happened. Okay. Now you're going to see a lot of card usage when we start talking about conditional probabilities. So as we look at this here, I've got the deck of cards here up already. We talked about this today in class as well. So I'll give you kind of an idea of what they're talking about with conditional probabilities. It says, 2 cards are selected in sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king, and the first king is not replaced. Okay? So, if I were to ask you what's the probability of selecting a king out of a deck, you would say, for a king, that would be 4 out of 52. Okay? So you selected that king. You took the deck, you selected that king, and this time you didn't put it back. So now, in order for you to find the probability of selecting a queen, there are 4 queens left in the deck. Now, there are not 52 cards anymore. There are 51. Okay? So what conditional probability is going to do is it's going to show you that you can find the probability of more than one thing at a time. And how does that first thing affect the second outcome? Okay? Not every time is your card going to be taken away and not replaced. Sometimes we'll replace it as well. Okay, so before we start figuring out how to actually find probabilities of more than one thing, okay, we're going to take a look at independent and dependent events. An independent event is the occurrence of one of the events does not affect the probability of the other event. A lot of times you'll see that you'll replace whatever it is you found the probability of. Okay? Or it doesn't have any effect on the second probability. Okay? So you find the first probability and it doesn't have any effect on the second probability. That's an independent event. A dependent event is the occurrence of one of the events does affect the probability of the other. A lot of times you'll see without replacing. So the last example that we talked about and showed, that was a dependent event. We took the king, found the probability of the king, we took it out, we didn't put it back in. That affected the second probability. Okay? That's a dependent event. So if it affects the second one, it's dependent. If it doesn't affect the second one, it's independent. Okay, so let's take a look at some examples here. Decide whether the following are independent or dependent events. Letter A, it says selecting a king from a standard deck, not replacing it, and then selecting a queen. So you take the king out of the deck, you don't put it back. Is that going to affect what your second pull is? Yes, it is. So this is a dependent event. It's a dependent event because you are not replacing the card. Okay? Letter B, tossing a coin and getting a heads and then rolling a 6-sided die and obtaining a 6. So you toss your coin, you may get heads, you may get tails. Then you're going to roll a 6-sided die. Does flipping the coin have any effect on rolling the die? No, it doesn't. They're completely 2 separate things. So this is an independent event. In this case, 1 has no effect on the other. Okay? And then the last one, selecting a jack from a standard deck, replacing it, and then selecting a 10. So from that deck, I pull out the jack, I put it back. Does it affect the probability of the second one? Since I didn't take it out, it's still the same kind of concept. So no, it does not affect it, so this is an independent. Anytime we put it back or replace it, it's independent. This time we are replacing. So it ends up being independent because it doesn't affect the second probability. Okay? So you're going to have to be able to identify independent and dependent events first in order to be able to figure out the probability, which is what we're going to talk about next. Okay, so now as we look at this now, we're going to actually find the probability now and put a number to it of multiple events. Okay? So this is what we call the multiplication rule. And you'll notice you see this word right here, and. You'll see this word and a lot. And what and means is that you're going to multiply, essentially. Okay? So the probability that two events, A and B, will occur in sequence. If they're independent, you just simply find the probability of A, the probability of B, multiply them together. Then one doesn't affect the other. Okay? If they're dependent events, you find the probability of the first thing, take out whatever it is you take out, find the probability of the second thing, that's what this means, and then multiply them together. Okay? All right, so let's take a look at some examples here. Okay? So again, you're going to want to go through this step-by-step process as we look at this. It says 2 cards are selected without replacing the first card from the standard deck. Okay, so whatever we're trying to find, we're not going to put it back. Find the probability of selecting a king and then selecting a queen. Okay, so if you look at your deck of cards, there are 4 kings in the deck out of 52 total. That's for the king. Okay? If I select a king and I don't put it back, to select a queen, there are 4 queens in the deck, and now, since I didn't put that one card back, there are 51 cards left, and I'm going to multiply these two to find the probability. When I multiply these two, I get 16 over 2,652. Top times top, bottom times bottom. And when I reduce that, you get 4 out of 663. So you have a 4 in 663 chance of selecting a king, not putting it back, and then selecting a queen. Okay? This, in this case, was a dependent event. One affected the other. All right? So let's take a look at letter B. A coin is tossed and a die is rolled. Find the probability of you getting a head and then rolling a 6. Okay, so the coin, the probability of you getting a head, there's one head on the coin, there's 2 possibilities. Does the coin affect the probability of the die? Does it take anything away from it or anything? No. So for the dice that you roll, I want to know the probability of rolling a 6. There's 1 6, there's 6 numbers. I'm going to multiply these guys together. This is 1 out of 12. You have a 1 in 12 chance of flipping a heads and then rolling a 6. Okay, this one here is just a little bit different, so I wanted to cover this using the multiplication rule again. It says the probability that a particular knee surgery is successful is 0.85. Find the probability that 3 knee surgeries are successful. Okay, well, will the first surgery affect the second is really the question that you're looking here. And if you think about it, the first surgery doesn't have anything to do with the second. So in this case, this is an independent problem. Okay? It's an independent problem. So what's the probability of the surgery being successful? 0.85. Well, we're going to do that 3 times. Because again, remember, it doesn't affect the probability of either one of these other 2. So when I do this, 0.85 times 0.85 times 0.85, those are the 3 probabilities. The probability of 3 knee surgeries in a row being successful will end up being 0.61. Okay? So that's kind of a different look as well at how you use the multiplication rule. Okay? All right, this concludes section 11.4 and 3.1. We talked in this section about independent and dependent events, and we also talked about using the multiplication rule. Okay, make sure that you take a look at your WSQ and complete that before you come to class tomorrow.